Hi, I'm Debash Datta, and in this video, I will be discussing the methods employed by Alessio Cardio and others in their paper, Structural Properties of Planar Graphs of Urban Street Patterns, to analyze the statistical and network properties of street network layouts of different cities. My partner in this project, Mark Miller, will be using the Bartolomei and Alessandro Flamini method of modeling urban street patterns to develop a network model for a city. I will analyze the statistical and network properties of the network generated by his model. So in this slide, we can see different types of street layouts. For example, San Francisco has a gridiron layout consisting of planned grids of perpendicular streets, whereas London, which is an old city, has a medieval layout, which is resulting from unplanned growth for centuries, which is usually the case in most older cities. Next, we can see Irvine in California. It has a lollipop layout consisting of many cul-de-sacs and dead ends, which is a layout often found in suburban areas. In this project, I will use network properties like cost and efficiency to quantify the differences or the qualities and how efficient these different types of layouts are. Okay. So for measuring the city street network properties, I will follow the same approach as was followed by Alessio Cardio and others. They used these three structural properties, and I'll be using this to analyze the street networks. They are the meshness coefficient, the cost, the efficiency. So in their study, Cardio and others, they use the meshness coefficient in place of clustering coefficient. The reason for this being, for many different planar graphs, such as square grids and a tree, they all have clustering coefficient of 0. So here the meshness coefficient is defined as f over f max, and where f is the number of faces in the graph and f max is the number of faces in the maximally connected graph, and their definition is further shown below. The next property is the cost. Well, the cost is simply defined as the sum of the lengths of all the edges in the network, and then it is defined by the formula as shown in the slide. The other property that we will be using is the efficiency of the network, and it is defined by the efficiency of flow in the network, that is the ease of traversal from one node to another. The efficiency for a pair of nodes, say I and j, in the network is given by the ratio of the Euclidean distance of the two nodes to the shortest path distance of the pair of nodes. The global efficiency is given by the formula shown. So here in this picture, we can see the blue line represents the Euclidean distance between the two nodes in the network, and the red line traces the shortest path between the points through the network. The efficiency of these 2 points is the ratio between the length of the blue and the red line. And the global network efficiency is the average of this ratio for all the pairs of nodes. Also, I'll be using this Python package called OSM-NX to further analyze the network, the city street networks. Um, so the so OSMNX is a Python package for downloading like street networks from OpenStreetMap. Um, it allows us to easily construct, project, or visualize and analyze complex street networks in Python. OSMNX is built on top of NetworkX, GeoPandas, and Matplotlib. So basically, we can easily analyze networks and calculate network statistics. For example, here in Figure 1, it calculates and plots the shortest path route between 2 points, and that to taking into account things like one-way streets. So here in this figure, we have like an origin and a destination, and we are tracing the shortest path between them. There's another example here in Figure 2. So OSMNX can easily visualize one-way versus two-way edges to provide a sense of where a city's one-way street and divided roads are distributed. Like for example here in this figure, we can see that in this plot showing the same thing which I just described. So I will be using this package on top of the cardio method to further analyze the city street networks. These are the credits. And thank you for listening.